So on example 6 then, continuing on from example 5, we are going to go through and try to find a way to solve for x. Now, when we read number 6, okay, it says the length of A to B is a length of 25. So I like to draw into, I'm going to switch my color here real quick. Go with red. So the length from A to B is a length of 25. Hopefully you realize, based off what we finished off with the previous example, letter F above, that we can take two smaller segments and add them together to give you a larger segment. This is something we called segment addition. Now, segment addition is what we call a theorem, where it's kind of one of those things of, oh yeah, that kind of makes sense. If I take two smaller segments, put them together, I get a larger segment. And that's what's happening on this example. So we want to solve for x. And I bet most of you can solve for x just fine. But as we also notice on this problem, is that usually you guys have not necessarily justified with this. Now, we talked about justification back at the very beginning of the semester. And most of you, I think, again, could set up the equation to solve. But I put this at step 2. And I'm going to come back to step 1 here in just a second, after we solve out for x. So step 3, we go about combining like terms. So we have what? 3x plus 1 equals 25. We subtract 1, we get 3x equals 24. And then step 5, we get x to be 8. Now, I have no doubt you guys could set it up to solve for x. But there's more to this problem than just solving for x. What I want to do here is justify my reasoning. So let me go back up to create a new step 1 that I don't think a lot of people usually have seen before. So when we do justification in geometry, we need to talk about what is going on in this problem. More specifically, are we talking angles, segments? Later on in the year, we'll talk arcs. What does 2x minus 6 represent? It represents the length of AN. So right above it, 2x minus 6, I'm going to put AN. And what did x plus 7 represent? X plus 7 represented segment NB. And what did the 25 represent? The 25 represented the large segment of AB. So this is, again, probably a new step for you now, where we want to first say, hey, we are going to add together segments AN plus segment NB to get a larger segment of AB. Now, what allows me to do that is what I start off with then, and it's called segment addition. When we start off the year, we were just doing, I said theorem earlier, this is actually called a postulate, I should say, and it's, again, still kind of the same of duh, makes sense type thing. But when we did at the beginning of the year, we just said most of the reasons were always going to be given because I gave you an equation. But now as we're moving through geometry, we are going ahead and having you create the equation based off of a geometry problem. So you got to give me now a new reason, segment addition being the new one. Now to go from step 1 to step 2, well, when I look at step 1 to step 2, I went from letters to then to, well, the links, the numbers. And the way that happened was I used what we call our substitution property. I replaced it, I substituted those in for each of the links. So we have the substitution property. So AN became 2x minus 6. NB becomes x plus 7. AB becomes 25. I substituted in. Now, talking about this all in real life, or I should say real life, but in person sometimes is a little bit easier than just following through these videos. Now, after that, once you get that done, it's what we've been reviewing with at the beginning of the year. To go from step 2 to step 3, we simplified, combined like terms. To go from step 3 to step 4, we, let's see, what else did we do? We subtracted 1, so we call that the subtraction property of equality. And then if we go from step 4 to step 5, we did our division property of equality. So the justifying part, most of it's going to be the same like we've been doing. But the new steps for today then is right here, this goes to, this is a new step right here of tell me what is adding together. We're adding together specifically what segments. And then the other new part for today is talking about, well, why were you able to add these segments together? You got to give me a mathematical reason why. And it's because of the segment addition postulate. And that, again, says if you take two smaller segments, add them together, you get a larger segment. Okay, so that's what we're going to continue working with. And then question 7 says, hey, from question 6, what is the length of AB? That is a typo. Because AB, we already knew, is a length of 25. It should have been, what is the length of, say, AN? So AN is 2x minus 6. I just locked in x to be 8. So 2 times 8 minus 6. 2 times 8, 16. 16 minus 6 is 10. So the length of AN is 10. If all goes as right, NB should be x plus 7, or 8 plus 7, which is 15. And together, that 10 and 15 should add up to 25. Check. That's what is the length of that large segment AB.